So, Sarah, continuing our ongoing saga on friction, what I've said to you is that friction depends on two things. It depends on this thing that we've called mu, the coefficient of friction. Really, you can think about that as your traction. Okay? High traction, high mu, you got good footing. Low traction, low mu. You can't have a negative mu. No, never mind. I thought the headphone was in your ear. Never mind. I totally misunderstood that. My bad. We looked at an obstacle course last class. We saw that actually friction doesn't have to be flat horizontal. You can also have friction on a wall. If you push against a wall, it will push back. Friction will be up. Gravity will be down because the normal force is coming out. We also said that friction depended on two things, mu, traction, and the normal force, which was related, Prith, to how heavy an object was, but that didn't take into account that when you lift up on something, it gets easier to slide. So I said a better indication is the normal force, because heavier objects generally have a bigger normal force, although I can lift up and cancel out most of that normal force if I want to. We looked at a few coefficients of friction. We said pause here. So let's look at example 8. Prith, you awake? You ready? Okay. Example 8, it's a dragster. Prith, you're going to be behind the wheel of this dragster. You got the helmet on, you got the fire suit, got the little tiny steering wheel. You can feel the body shaking underneath you. You can feel the rumble in your belly. This is all good. Prith, what's part A asking me to find? You mean A is asking me to find A? You'd almost think I planned it that way. So I'm going to do this. But now I have to plan my attack because there's a bunch of ways to find acceleration. Two main ones. There is using forces. Don't write this down, just watch. And there's using all of the VF, VI, D, that stuff. Which method am I going to use here? Let's look at this. It says, I'm going to read the question, a 540 kilogram dragster. Oh, that's a map. Maybe I'm going to use this. I keep reading. Accelerate it from rest. Oh, Prith, what does from rest mean? You know, that's suggesting maybe I'm going to use this stuff. I keep reading to a speed of 32. That's really suggesting I'm going to use this. In a distance, that's really suggesting. Also, what's part B asking me to find, Prith? You know what? If I don't know the net force, I can't use this method to find the acceleration. In fact, I'll bet you in part B, I'm going to go F equals ma. Which A? My A from part A. So, you know what? I think I've planned my attack. And I did that little dance on purpose, Lindsay, to let you know this is how my brain kind of approaches these. Courtney, how do I know what to do? I kind of use a process of elimination. So I'm going to now say, well, you told me VI was 0. What was VF, Prith? Really not that fast. I'm going to change the numbers next year and go faster, but okay. And D is positive or negative? Are you going forwards or backwards? Are you positive? Okay, sorry. No? Okay. Hey, Prith, have you got an equation that has those things there in it? Which one? Do you feel up to getting the A by itself? Sure. Okay. I agree with you, but I can see from the crowd that I lost a few people. Just to jog our memory, this is important that you know, Cohen, that all of this stuff is still fair game, all of the stuff from before Christmas. The only thing that's not going to be on this test, Alex, is relativity. And I guess I'm not going to put a bunch of graphs on the test, but the equations, yes. Okay? Cohen, we said if I'm trying to get the A by itself, the VF squared is going to drop down like a domino because it's already on the opposite side. I would minus the VI squared over. I would divide by the 2D. That's what's going to give me the acceleration. And that's what you said, Prith. I agree. So it's going to be 32 squared minus 0 squared all over 2 times 64. You know what? I can do this in my head because 0 squared is 0. 32 squared, Megan, is really just 32 times 32, and that 64 on the bottom is 2 times 32. One of the 32s will cancel. I'm going to end up with 32 divided by 4. It's going to be 8.0, 8 even. Yes, double check me, but yeah. Units, Prith? Meters per second. And you know what? That's not that big an acceleration. That's less than 1 g. I was making up numbers. I'm going to next next time I retype this, I'm going to look up what a typical dragster gives you for an acceleration. I think it's higher than that. Sorry. Brett's just a lousy driver, and I didn't want to scare him. Sorry, Brett. Okay. Hey, Matt, what's part B want me to find? What force? That's my code to you. That's my way of saying, look, when you go winner minus loser equals F net, I'm just asking you to worry about the right side. You don't need to do a free body diagram. You can just go straight to that there. Although, why don't I move this over? Do I know the mass, Matt?
Yeah.
What? Do I know the acceleration? I just figured it out. What? You know what? Multiplying by 8, that's just the same as going times by 2, times by 2, times by 2. I think I can do this one in my head, because 540 times 2 is going to be 1,080 times 2 is going to be 2,160 times 2. 4,320? 4,320 what? Units. It's a force. Yeah. Oh, and it should, oh yeah, newtons. Have I mentioned it's worth memorizing units? Yeah, it really is. 4,320 newtons. By the way, oh, hang on, we're going to come back to that at the end here. Connor, what's C asking me to find?
Friction.
Friction equals what times what? What times the normal force? What's another English phrase for mu? What do we call that in physics? Coefficient of friction. Look at the question. Have I given you mu in the question?
No.
What's part D asking me to find?
The coefficient of friction.
So although my first thought, Rebecca, don't write this down, but my first mental thought would be mu times the normal force, I would then say, that's not going to work. What else haven't I tried in my bag of tricks? What I call the Swiss Army knife of forces. Let's do a free body. You know what? I haven't done a free body diagram, and there does seem to be, you know what? Let's try that. There's the dragster. What are the forces acting on it? Get the obvious one. What else?
Normal force.
Same size, I believe, as mg, yes? And now we'll see how good you are. What else?
The friction between the tires and the wheel.
Which way?
Right.
Connor, you just impressed me. Did you hear him? Except I heard, right? He would have impressed me completely if he had looked me in the eye and he had said, to the right. Ready? Here's my thinking. Sheldon, what direction is this car accelerating? Forwards or backwards? I'm going to ask you the same question. I'm just going to phrase it differently. Which way must there be a winning arrow pointing? Which way must the winning force be? So I would do this. And then I would say, hey, what force is that? It's not an applied force. Why can't you drive on ice? What force pushes cars forwards? Okay. Is there a force to the left? Well, we're going to ignore air resistance. Oh, you know, your dragster is nice and aerodynamic. And I think I told you last day when we looked at air resistance, unless I mention air resistance, assume it just doesn't exist in our magic physics world. This bugs kids because, by the way, you'll notice how different this is. Connor, in all of the previous questions, friction was slowing us down, pointing to the left. Friction was slowing us down, pointing to, whereas friction slowing us down, pointing to the left, pointing to the left. Here, yeah, it's speeding us up. And that's because the tires, if you follow the tires around, the tire pushes backwards against the road. Newton's third law kicks in, so the tires apply a force to the road applies the force to the car. And I'm only drawing the forces on the car, on the dragster. So, you ready? Who's winning? Yeah. Who's losing? It's a trick question. No one. So when I go winner minus loser, it's going to be winner, no loser. Is that okay, Hedrick? And what does that always equal, Connor? Say that again. What does it always equal? Say that one more time. What does it always equal? No, 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 no. You're right. I'm repeating this for a reason. What does it always equal? What does it always equal? What does it always equal? Are you saying that I can just go 4,320 because I've already done MA in the previous line? In other words, do you see the reasoning we did here, Megan? Connor, what did you say they wanted me to find? The force of? I didn't use mu times the normal force. I used winner minus loser in a free body diagram. How did I know to do that? They didn't tell me what's mu. I don't know what's mu with you. They didn't give me the coefficient of friction. Andy, what are they asking me to find in part D? Is there an equation that has mu in it? What is that equation? So you're saying part D is asking what's mu? I don't know what's mu with you. It's asking what's mu? How would I get the mu by itself? Okay, okay. So you're saying it's going to be friction divided by the normal force. Do I know friction? What? I don't know the normal force. Oh, but look. I know another force the same size as the normal force in my free body diagram. Which force conveniently happens to be the same size as the normal force? Alicia, see how we put all that together? And by the way, don't kid yourself. This is a lot of reasoning to go to, which is why I'm spending so much time on this. We're using Newton's laws, Alex. We're bringing in some formula manipulation. We have now multiple strategies to choose from. Yeah. But this is how, if you were this dragster tire company, you would advertise your coefficient of friction. You would drive your dragster at a certain speed. You would time how fast it was going. You could use that to figure out your force of friction like we did in part C. Then you would know the mass of your dragster because you designed it, and you would say, our tires have a coefficient of friction of 4,320 divided by 540 times 9.8. Sadly, this one I can't do in my head. Yeah, I know. Yeah, Mr. Dewick, you let me down. Uh, 0.816, is that right? What are the units for the coefficient of friction? There are none. Okay. How could I change that at the racetrack? Have I talked about this, what dragsters do? Oh, I talked about this the other day, right? Yeah, you do a smoke show because melted rubber, hot rubber, is stickier. So that's why they do the smoke show before they actually do the race. And yeah, the crowd loves it. That's like a bonus. Hey, it's entertaining, But it's good physics. Last one. Cohen, what's example 9 asking me to find, my friend? Acceleration. The net acceleration, I think that's a hint that may, it wants the MA part. Look at my picture. Have I got several forces in the picture? You know what, this is a job for a free body diagram. Although instead of redrawing everything, Cohen, I'm just going to label the stuff on my picture. Y'all ready? What are the forces acting on this box? Get the obvious one, folks. What else? That's called resonance, but we don't look at that in physics in high school. What else? Normal force? I agree, because is it sinking into the ground like quicksand? Is it flying in space? Bigger, smaller, or the same size as gravity? Did you hear Andy? He said bigger because there's an extra 20. Oh, wait. Remember, what we're really saying is everything up has to be canceled by everything down. So is the normal force having to cancel out all of gravity, or is that 25 canceling out some of gravity? So I think the normal force gets to be smaller. I think, Alex, both of those cancel out gravity down. Is that okay? What else? Is there friction in this question? How do I know that there's friction in this question? Okay, I'll make it pretty obvious, Alicia, in the diagram. Or if I don't want you to have friction, I might put wheels on the car, on the box. That's my, or I'll just say mu is 0, it's ice, or something like that. I'll say it's frictionless. But otherwise, there's a mu. Which way would friction be acting here? Which way is this box sliding, Cohen? To the right. So which way will friction be acting? I agree. And I'm pretty sure it's smaller than that 45. There. Is that okay, Cohen? Look at my picture. Who's winning? Oh, you know what? Let's call this is what we've called the applied force. It's someone is off stage with the rope pulling. I don't care. I'm not interested in what's pulling it forward. I just know an outside force is being applied to the box. We'll call it F applied. Who's winning? Ah, good. That way you could use the physics term. Cohen, who's losing? Yes. What does that always equal? Yes. Good call. Cohen, coming right back at you. What's this question asking me to find?
Kinetic acceleration.
Oh, the A? How would I get the A by itself?
You divide it.
Yes, see, I remembered the other day. Now you got it. Divide by what? M. Yes, because I want the A to stay there. In other words, whenever you say divide it, I worry you're saying, oh, you divide the A. Well, no, that would put the A on the bottom and not have it by itself. And bleh. I want the A to stay there. I want to get rid of stuff in front of it. So divide by the M. So if I hear you correctly, Cohen, you're telling me this. The applied would drop down like a domino. Yes? Friction would drop down like a domino. Yes? And you're telling me that whole thing is divided by M. Yes? And if you're okay, do you mind? I'm going to put the A on this side. A equals, because we're used to seeing the thing by itself over there. Let's keep going. This is going to be, now, in your homework, Rebecca, you might start combining some of these steps, and if you do, Ryan, great. You know, like in other words, if you're feeling comfortable with some of this, great. In our notes, I'm going to write every thinking step that I'm doing here. So now my next line, I would drop the F applied down, minus, and I would say friction is what times what? Mu times the normal force. Right? I don't know the normal force. Oh, but look. I know some other forces the same size as the normal force. Andy, can you give me an equation that tells me how big the normal force is?
Normal force equals mg minus 25.
So Andy got there in his head, and that's great. He said normal force equals mg minus 25. If it's ugly, here's what you really need to realize. Ready, Andy? Is it sinking in the ground like quicksand? Is it flying like Superman? The reason I've done that stupid little chant, what I really want you to realize is all the forces up balance all the forces down. All the forces up equal all the forces down. If you need to, and you can in your notes, just so you know where it came from, if you wanted to, you could write all the forces up, which are those two, yes, equal all the forces down. And I'm willing to bet, Cohen, if you jotted that down, and then I said to you, how would you get the Fn by itself, Sheldon, you'd say, oh, at minus 25, mg minus 25, okay? And if you can do that in your homework in your head, great. But if you're like, there it is, pops out of there too, okay? That's the vertical force equation, but it's not accelerating, it's a tie, so I can just say everything up equals everything down. So what you're telling me then, Andy, is it's going to be F applied. Well, you know what? Let's start plugging. Well, no, let's do this algebraically, Mr. Dewick. Mu, and then you've told me it's going to be mg plus 25 or minus 25? Minus 25. Let me pause so you can see where everything came from. It's mu times the normal force. Let's do a quick double check. Cohen, do I know F applied from my picture?
Yeah.
Do I know mu from my picture? Do I know M from my picture? They don't need to tell me 9.8. Do I know M from my picture? I do a quick check. I know everything. Now it is plug and chug. Fairly complicated plug and chug, sure, but plug and chug. What was F applied? 45? Was it? 45 minus, what's mu? 0.36. 5.8 times 9.8 minus 25. And this is a great one for you to practice with your calculator. This one I'm not doing in my head. I just remember the answer is really close to 5.8 because it was really close to the mass. And I made a mental note that next year I'll change the numbers a bit just so that people don't get the mass. And is it like 5.78 or something like that, I think, when all's said and done? Yeah. This is also your time to figure out how to type that in. Oh, Cohen, is this a big fraction? Is there more than one thing on the top? Better put the top in brackets. And this also, Cohen, already has to be in brackets, so I'm going to end up with a big uber bracket, 45 minus 0.36, open bracket, 5.8 times 9.8 minus 25, close off the mini bracket, close off the top. Cohen, is there more than one thing on the bottom? Do I need brackets on the bottom? You can, but... And there's the 5.78. 5.78 what, Cohen? It's an acceleration. Units.
Meters per second squared.
Yes. You know what? That one gets a celebration box because that took a bit of work. Matt, I haven't covered every possibility. I can't. There's going to be questions in the homework that I haven't done that specific example, and it's going to be, well, free body diagram, winner minus loser, write an equation. Look for words like steady speed. That means A is 0. Look for... I just can't, I could keep going and going and going. Your homework is everything. So I've already assigned 1, 2, 3, 4, 5. 6 is fair game. 7 is fair game. 8 is fair game. 9 is... That's a lot of homework. Yeah, I know, and I see you guys tomorrow. I'm going to say you want to get this done by Tuesday, but I am going to be giving you some more stuff tomorrow also, unfortunately. We're just in the home stretch. I really want to get your test before spring break rather than after spring break. The nice one we'll talk about next class is number 14. Number 14 says this: Connor and Liam are astronauts working in weightlessness on the International Space Station. Connor takes a box of mass 45 kilograms and he pushes it towards Liam at 2.2 meters per second, so the box drifts across the cargo hold. Liam decides to stop the box with his face. Will it hurt? In 0G, will that hurt? Or if you really want to be poetic, if Matt and I are in 0G, could we have a boxing match? Or will the whole punching thing just not work at all? If I don't have any weight, will me hitting Matt hurt him at all? I'll let you think about that. We'll talk about it next class. Now, we are going to look at a Mythbusters video.